Hi everyone, thanks for joining me. I'm going to go over the templates that you'll be able to download pretty soon, and these are going to make it really easy for you to have your one table figure and your two graph figures displayed in the final paper. So you imagine the citations, the references have ended on the previous page. You start a new page, and you really just need to paste this into your Word document. So you just copy paste this into your Word document, and then you'll have almost everything in the correct format, right? You'll have your table one, mean, standard deviations, percentages for study variables. And you just have one table where you'll consolidate all of your continuous and categorical variables. So you can manipulate this, right? So some of you might not be looking at credits, you might be looking at GPA. So you'd put, GPA. So you just replace it with your own variables. I'm going to switch it back to credits though. Notice that for this example, age and credits are continuous. And then we have gender, class rank, or categorical, and then there's kind of like a little indent where you actually display the levels. Depending on whether or not your variables are categorical or continuous, you'll need to keep track of which type it is, just because the type of information you put into this table is going to differ based on which type it is. So for age and credits here, they're continuous. So we're going to have the mean. And so all this information, just as a reminder, if you watched the previous video where I'm going over SPSS output that Kati and I have sent you, in that video I show you how to get all of this information and some. So basically, just if you're not sure where these data come from, you got to go back and watch that video, because in that video I actually go over how to extract the information. But this is just say the mean for age, and then in parentheses here I have its standard deviation. The range you're going to generate from the minimum and maximum values. For categorical variables, we don't care about means or SDs or ranges. For categorical variables, we only care about the percentages, those percent columns. If you're missing data, I've recommended that you use the valid percent column. Really, you're doing it correctly though if the percentages for each categorical variable add up to 100%. So in this particular example, we have 55% male, 45% female. Right here, class rank is not just 2 levels, it has 4 levels. So we have all these percentages, they should all total to 100%. Notice we don't have ranges for the categorical variables. So easy enough, the table, you don't really want to mess with any of this, right? You don't want to mess with the template too much. Just replace the text with what's appropriate for your experiment. So you're really just replacing this in the table. But everything else you're kind of just copy and paste. So, and also make sure to read these comments once you've downloaded this. So on a new page, you're then going to put your two figures. You'll probably actually have your scatter plot as figure 1, and you'll probably have something that looks more like this right here, down here as figure 2. So for now, you shouldn't pay too much attention to the actual type of graph we're displaying, but what I really want you to pay attention to right now is where the stuff is, right? So you've got a graph, your first graph here on the new page. It has a figure caption, figure 1, and then the first sentence is basically more or less your title for the graph. Notice there's no big title up here. We put our title as the first sentence in the figure caption. It says the effects of eating a large or small bowl of Wheaties on quiz score performance. It's just telling you what are the data that are being displayed. And then the second sentence goes as far as to explain some of the results to you, saying those eating a large bowl of Wheaties had a significantly higher, it should say higher, P is less than 0.05 quiz score than those eating a small bowl of Wheaties. So it's telling you, this taller mean here actually is in fact statistically higher. So this is more or less telling you, you should eat a large bowl of cereal if you want to do well in your quiz. So, so that'd be your first graph. Your second graph is going to be Where it's the same, right? You're gonna have a different graph. It's gonna be a different looking graph, but you're gonna have, figure name is gonna be figure 2 because it'll be the second one, and then you are going to have a title just like this one. The first sentence is more or less just a title, like saying, what are the variables? What's on display? We're looking at the effects of the type of school program on writing score. So how does, this stuff listed on the x-axis, how these different levels, how might they, separate when looking at the mean writing score? And they don't appear to, right? There's a lot of overlap here. And then the results part right here in the second statement kind of supports that idea, right? It's saying that there was no statistically significant differences. P is greater than 0.05 in writing score based on the type of program a participant was exposed to. So this isn't bad. So these should be pasted in as images. So these would be pasted as images, but where they're coming from is actually this other template that you'll be able to download. And what you basically do here is this is plotting. So it's a 2D plot, two-dimensional plot of your IV on the x-axis against your dV on the y-axis. So for this particular experiment, I guess their hypothesis was, people, tend to, if they're studying more, they tend to study everything maybe a little bit more. So if math score is going to increase, writing score should probably, there should be a positive linear correlation. That's what they expect the relationship to be between the math score and the writing score for all these participants, all these observations. So, so each of these pairs. So let's say this is a person. They got a writing score of 59 and a math score of 53. All right. So let's look for writing score. 59 is about 60. Math score is 53. So it's somewhere around here, I can imagine. So, this observation is going to be around here. So it's just showing you, it's just plotting each of these pairs, which means that if you were to copy and paste your data here, it will actually replace all these points with your data. So like the last example, don't mess with anything that you don't have to in these plots, right? You don't have to actually interact with anything on the graph except for these labels to change it, right? So your IV isn't math score probably. So you're going to want to change this label down right here. You just delete and rewrite the text, and you would do the same on the y-axis for your DV, whatever your DV is. So you're only interacting with this actual image or this actual graph to change those things. Like I already said, everything else is just pasting in your continuous variable data, and it will just automatically plot here. One thing to keep in mind is that the DV is actually on the left column here, and the IV is on the right column. So make sure you're pasting yours in the correct position, because we do want the IV to be on the x-axis and the DV to be on the y-axis. And just to show you what I mean, a little further as to what I mean, if I were to delete any one of the two values in these pairs for an observation, notice those dots are disappearing. And notice that little line of best fit that's supposed to kind of map out and display for you the slight, positive linear correlation between math and writing scores. Notice that that's changing as a function of the points disappearing, because it's in real time just automatically generating this stuff based on the information in these columns. So if I undo and put these values back, you notice those values are then getting added back to the scatter plot, and then the line of best fit is adjusting to minimize the distance of all the values from the line itself, and really generate that line of best fit, which is really supposed to display for the reader that it seems that there is some sort of, at least visually here, it looks like there's some sort of small to almost moderate positive linear correlation here. And I can just, even without looking at the output of the correlation test, I can kind of start to see these things just looking at the visualization. Now, yeah, so it's just changing these labels, changing the data, and not really interacting with the graph. Otherwise, what about our t-test? Well, it's similar when it comes to changing the labels. So, size of cereal bowl, you just delete the text and type new text. Same with the y-axis, we're changing that to your DV. So this is your categorical, this is your DV for the t-test. And you also have for your categorical variable, you break it down into the two labels, right? The two ways of categorizing, where you have either a large bowl or a small bowl. To change that, you're going to want to change it by, typing something different here. So I just type gibberish there, right here, and you notice that this changed. So now the way the level is labeled can be changed through just changing the text here in these fields. So just a reminder, yeah. So if you want to change this label, you just interact with it and delete it and rewrite it. But if you want to change these labels right here, you actually have to change the text in here, and it'll automatically update down here. Now, this group statistics table should look almost identical, if not identical, to actually, I just realized something. Just to make sure everyone knows, we did send you this raw output. So if you can't find this for my students, maybe I put them on two different tabs. So check your Excel sheet I sent you and look at that other tab. You'll see I have all the raw data I pasted for just your two continuous values. So you can do this copy and pasting thing. So just to make that clear, yeah, I almost forgot that. So we did not just give you all that output, but we also gave you back this stuff just because you need it right now to plot the scatter plot. But anywho, okay, so I had that little detour. But now going back to this, the group statistics table should look very similar to that group statistics table in your SPSS output. And similar to what I said in that video, the means and the standard error of the means are the important values you want to extract from those tables, because those are actually the values that are plotted here. So these mean values are basically the height. These numbers are the height of the bar graphs, or the bars on this graph, looking at the y-axis. And then these very small little thin bars going up and down, those are the standard error of the mean bars. So if I were to change this, I'm going to change this to 20. Oh, a little tall. We'll get to that in a second. Change this to 30. They're both resizing. They're both getting taller to those values. The standard of the mean. So the error bars have changed as well. You can't quite see it, but we'll see it in a second. So how do we fix this? Well, we just need to make the maximum value of our y-axis a little taller, right? So I'm going to double left click on my mouse, and there's a pane that pops up right here. Oops. Make sure you hit the numbers. Yeah, so you want axis options. So I'll do one more time. Boom. So you want axis options to display. So I double left clicked. If you don't see this stuff, then you might want to click on this axis options thing and then click axis options. But you're going towards axis options. And we can see here that our highest, you want to look at your highest mean for your bar graph, and this is 30. So we know our maximum of our y-axis has to be at least 30. But then if we see that its standard error of the means, like 5.5, you add 5.5 to that, it's 35.5. So let's just go ahead and go to 40. Let's see what that looks like. Nice. Okay, so now we can see the tops of our bars, and we can see the length of our error bars. But the issue now is we're incrementing by units of 1 on our y-axis, and since it's 40 or really 41 values total right here, we need to start getting rid of some of the labels just so we can see things, right? It's getting bunched up. So let's go ahead, and I'm going over here, I'm changing the major units to 5, and that cleans it up, right? Because now the reason it's cleaned up is because every increment, every time the values going up, it's going up by 5. So it cleans it up. And now let's see if everything's plotted correctly. So, so for this example, if we're doing sizable, we won't have to change labels because we're looking at size of ball and the effects on the size of ball on our quiz score. Our manipulation text is correct, right? Small ball versus large ball. Small ball's got a mean of 20, so 20, good. Large ball has a mean of 30, so notice it automatically just put it at 30. And then our standard error of the mean, 3.2 in either direction, so it's about 3-ish that way, about 3-ish that way. This one's going to be about 0.5 this way, 5.5 this way. And it should make sense where, this is larger than this is taller than this. And if this is larger than this, then this bar here should be longer than this bar here, which it is. So that gives us some good information that it's probably, correct, is plotting things correctly. So I hope this was helpful. Again, if there's any real questions with this, always remember to email and contact Katya and I. I'll make one final video talking about how to do the discussion section in a little bit. But I hope this was helpful. Thanks for watching.